This meeting is being recorded.
Alrighty. Hello, everyone. If you're watching this video, thank you very much. It's exciting to see that we have some veterans out there that are interested in pursuing a career in science. My name is Tim Philbeck, and I'm a PhD student in the Biomedical Sciences program here at the University of South Carolina, as is Rahil and Mansi. If you're interested in industry positions, there's their email. You can absolutely contact them and inquire about, how to get there, what are the options out there. Also of note is my email at the top there. Please contact me if you're interested in, discussing science in any capacity. I do want to mention that we are in the very early stages of establishing an organization aimed at, developing a network that veterans can access to discuss and meet with individuals who have been successful in their particular career of interest. So if you're interested in, later on in engineering, position, hopefully we have an engineer by that time who's willing to meet with veterans and talk to them. So please reach out. I'd be happy to talk to you. So this is just a slide to share my story on how I transitioned from a career in the service to a career pursuing science. In 2013, I enlisted in the Marine Corps as an infantryman. I spent the next few years in Hawaii at Kaneohe Bay. And in 2017, because one enlistment wasn't enough, I went ahead and signed up for a second one and was stationed at Quantico, Virginia. I spent a lot of time as an instructor there. In the latter half of my career, I transitioned to a maintenance position that allowed me to, start going to school while I was in. In 2021, I separated from the Marine Corps and began attending the University of Mary Washington. It's a small liberal arts college in Fredericksburg, Virginia. And this past summer, I graduated with a Bachelor's of Science in Biology. And later that year, this fall, actually, I started attending the University of South Carolina. So go Gamecocks. If you're left wondering, how did a knuckle dragger like me leave the infantry platoon and find himself in a PhD program? I'm right there with you. I'm still trying to put all of that together. But there did come a critical point while I was in Hawaii that kind of piqued my interest in pursuing a career in science. Specifically, I had a mentor of mine tell me a story where he and a best friend of his were pinned down in Afghanistan. His friend was responsible for manning the machine gun at that time. Instead of doing that, he crawled into the fetal position and lied on the ground. The stress had simply got to him. My mentor, for lack of a better phrase, grabbed a hold of him, smacked him around a little bit, and he hopped up, got on the machine gun, and they both made it home. So in that very moment, when he told me that story, I started wondering, what makes him different, from that friend? How was he able to persevere in the face of extreme adversity? And so that's kind of how I ended up here. I started, looking into psychology books, into, neurobiology, and I eventually found a love for neuroscience. And so that's what I'm studying here at the University of South Carolina, is the neural mechanisms that really underlie behavior. But that's enough about me. So here's a really brief outline of the topics we'll cover for the remainder of the presentation. I'll give you some data in terms of, how many veterans are pursuing STEM careers as a whole. We'll talk about what STEM is, and then we'll kind of zoom in a bit and talk about some of the career options that are, specific to science careers. And then hopefully, we'll be able to answer any of your questions if you email us. So please do. We would be happy to have a conversation with you. So what is STEM? So this slide isn't meant to insult anyone's intelligence by any means, but if you saw this acronym and maybe wondered what the letters stand for, it's science, technology, engineering, and mathematics. And included in those are some of these, occupational pathways. Today, we're going to be focusing on the science portion. So that's your life sciences, your natural sciences. Some examples include biology, chemistry, biochemistry, physics, geology, and astronomy. So how is STEM looking as a whole compared to other occupations? So by 2032, it's expected that STEM is going to grow 3 times the rate of non-STEM occupations. And interestingly, veterans are more likely to pursue STEM occupations than non-veteran counterparts. And it's interesting also geographically that, being located here in South Carolina, you're uniquely positioned to really start reaching out to people at specific companies or academic institutions to really start building a network if you're really interested in pursuing a career in science. Because if you look at the states with the largest concentration of STEM occupations, they're all on the eastern seaboard. You have Florida, Georgia, North Carolina, South Carolina, and DC. So this is a good place to be. The graphic at the bottom just kind of shows the breakdown of how veterans are using the GI Bill and some other, extramural funding sources through the VA. You have a really large portion interested in the computer information sciences and support services. And then you have a good portion interested in health professions, your doctors, your nurses, you have engineering, and then some other STEM fields and the biological and biomedical sciences. But I really want to focus here on the health professions, okay? Just to kind of combat some of the recent news that I've learned about successful high school students who might be interested in chemistry or biology. If you're interested where this data came from, here are the sources for that. And so taking a look at this graphic, and we'll discuss again, as I alluded to, the idea that if you are interested in chemistry, biology at the high school level or successful at it, that maybe you should pursue a medical degree. And I think that's an absolutely noble cause, and doctors are absolutely needed. But if you take a look at the median weekly earnings and the unemployment rate, it's all comparable, okay, in terms of how much you can earn with a doctoral degree. The earnings is comparable. And then as you advance, starting with a bachelor's degree, really, you start to be insulated from the unemployment rate, if the country falls on hard times, for example. Here, I just want to mention this is not a recruitment slide, okay? I'm not trying to convince you to go for a doctoral degree at all. I just want to show you that there are other options out there, okay? Being a doctor is absolutely one of them, and we need them, but there are other options. So now getting kind of more in depth into the major employment pathways for people interested in science. You have academia, industry, and policy. Starting with academia, you can go the administrative route. You could seek a faculty position and work your way up to a deanship. Okay, the dean of science, for example, at a university, you'll be completely adjacent to the groundwork. However, you will be influencing policy a little bit at the academic level. You'll be driving the ability of students to receive funding to conduct their research. So you would play a pivotal role in the science that happens at an academic institution. You have your research assistants, your lab techs or lab managers. So these are individuals who might be interested in doing science on a daily basis, but might not want to deal with the rigor of applying for funding, which is a major hurdle, for faculty members or teachers and researchers, which is the area we're going to focus on more today. Industry, you have your biotech and pharma sector, data science and consulting. And we're going to focus on biotech and pharma today, but here we're talking about private companies, that are doing independent research, typically for profit. In the policy sector, you have advocacy. Something that comes to mind here is animal advocacy groups. Okay, so research is often conducted with animals, and there are several groups out there that ensure the proper handling and management of those animals throughout the duration of all research projects. Absolutely, we need communicators. So there's complex science happening in these labs, and someone has to be able to kind of, disseminate that to the public in an effective manner. And then project management, which is our third focus. And here I just want to, we'll get into it more in just a moment, but this is particularly appealing to veterans that I've spoken to anecdotally. Okay, you have leadership skills that you've gained in the military, and that makes you an extremely appealing candidate to fill some of these roles. Okay, so how it pertains to science, you might manage people or the details of the project, but you would absolutely be able to put your leadership skills to use, and we'll talk more about it in just a moment. But starting with academia, so teaching. So K through 12, this is your basic teaching roles. You're going to teach basic science to students, your basic chemistry courses that you can think back to high school, middle school, or elementary school. The requirements here is kind of one of the pros when it compares to collegiate faculty members. Okay, you only need a bachelor's degree, a state issued certification. You have to pass a background check. Now, transitioning to salary in lieu of providing you numbers, because is affected by so many different factors. We wanted to present you with some of those factors, okay? And the salary is going to vary based on location, school size, and whether the school is public or private. Okay, so this is going to require a little bit of legwork on your end to find out the specific salary range in a given area that you might be interested in looking. Now, the projected growth, there really isn't growth. In fact, there's a slight decline here, okay, expected by 2033. And so each year, especially around election time, there's advocacy groups fighting for teachers' rights, benefits, and increased salaries. And so, this is just my hypothesis at what's going on here is that, there's not an expected growth due to those shortcomings that people are trying to resolve. But there's obviously work left to be done. Now, transitioning to teaching and researching at the collegiate level. Okay, your role here is going to shift. So here you're going to mentor and instruct students beyond the high school level. And I just want to talk about mentorship for just a second, because this looks different depending on what type of school you're at. So I attended a small liberal arts college where, the instructors there were not considered mentors, they were considered advisors. So they ensured that everyone was on track for graduation. They were taking the correct courses. However, at some of those institutions, research does occur. In fact, I participated in 3 years approximately of research as an undergraduate, and I still consider my advisor a mentor of mine. I mean, I learned more from that individual on how to conduct science, how to prepare an experiment, learned more from that than I did any undergraduate course. However, if you're in a larger R1 university, like the University of South Carolina, for example, your mentorship is going to be more of an emphasis. At these larger institutions, you'll be required to teach less. Okay, so there's a balance between your required teaching hours and research hours. And so if you find yourself at a larger institution here, you won't be required to teach as much, and you can really focus on your students that you've recruited in your lab. The requirements here are a little more involved, okay? You need a master's degree and a PhD, which is often referred to as a terminal degree. You can teach at the collegiate level with a master's degree, but you're not eligible for tenure track positions, certain benefits, and typically you're not allowed to work full time, which is kind of tied to that lack of receiving benefits, okay? The salary here is going to be pretty similar. It's going to be affected by the same factors. It's going to vary based on location, school size, and whether the school is public or private. Now, the growth here is looking good. Okay, we got an 8% growth expected by 2033. So there's going to be, as schools grow, the departments grow, there's going to be more job openings, and there's a booming interest in science in general. So it's a good time to get in if this is something you're interested in. Taking a look at the biotech pharma industry, here's where the roles and the requirements really give way to a lot of variety, okay? If that's something you value, having many options, this might be an industry for you to look into. The role here, you're going to manage projects as it pertains to research and development. You could be involved in the business side of things and the development that goes into that. You could work in sales and manufacturing. I mean, the variety of options here really is vast, and this is a good place to be if you're not really sure what you want to do yet, but maybe you want to feel some things out. Maybe you could break into this industry and give it a shot. Excuse me. The requirements here, you have a bachelor's degree for entry-level jobs, master's degrees, PhDs. Again, it's all about variety. So you can really get into this sector pretty early on, but this is where networking comes into play. And so that organization that I mentioned in the beginning, we are hoping to take some legwork off of building networks and interacting with individuals within a network. We're hoping to get that going for you. But in the meantime, if you want to go ahead and get a head start, absolutely start reaching out to people if this is something you're interested in. Sending cold emails. I know it's maybe awkward at first, sending out 20 emails to people you don't know. But if you send a good email, it only takes one. Okay, it only takes one, and then once you meet that person, you can kind of break into the industry in some capacity. The salary here is going to vary based on experience, qualification, location, the company size, and whether the company is private or publicly funded. Also, I want to mention here, the age of the company really matters. Okay, if it's a startup company, that's something that you should consider when you're looking into that company. Okay, if it's a younger company, a lot of companies don't make it. Okay, so you are accepting some risk by trying to break into the industry from that avenue. If it's a more established company, your job security is going to be a little more insulated. The projected growth here, again, it's a good time to get into the sector. Okay, increase of 7% by 2033. A lot of variety, a lot of opportunity. So project management. So again, as I mentioned, this is where your leadership skills and ability to manage people, the budget, scheduling, staffing, details of a project, you're really going to have a voice here. Okay, and your management skills will be tested and put to use. So this is kind of appealing to some veterans who might be interested in using some of the skills they gained from the military in the civilian sector. Okay, which doesn't happen all that often. As I mentioned, I was an infantryman, and those skills do not translate. Okay, I don't use anything I learned anymore these days, except the leadership skills, I would say. The requirements here are bachelor's degrees, master's degrees, or PhDs. So you still get some of that variety here. And just anecdotally, if you do a job search on Indeed for project management, science jobs, or anything of the sort, you will see there are a ton of jobs open. So the opportunity is ripe for the taking. Salary here is going to depend on the company, the size of the company. Okay. And again, the projected growth here, 7%, good time to get in, good opportunity. If you're interested in utilizing your skills, maybe take a look into project management. Now I put this graphic here, and if we had some in-person participants, I wanted to pause a second and have you take a look at this graph and tell me, why do you think epidemiologists, are growing at a near 27% rate? And then, if you're watching this recording, you can pause the video, maybe come up with a rationale, but if you think back to 2020, okay, it makes total sense that there'd be a sudden interest in epidemiology work. Okay, young people want to be more prepared for the next pandemic that might break out. Okay, hopefully we don't think the sky is falling and the world is ending the next time an illness starts to spread. We'll be hopefully better equipped with all this interest in epidemiology. Now, I wanted to leave off by providing you with a tool. So the American Association for the Advancement of Science is an organization that you can go to the website, go to the Science Careers tab, and you can search a plethora of science careers. There's so many out there. They have resources on that website. It's something to check out if you think that maybe you want to break into science, but you don't know where you want to go. You don't know if you want to look into academia, or you don't know if you want to look into industry or policy. And there's so many more other options in addition to those three major employment sectors. That there's several, but really just put the legwork in, do some research, and then please, if you would like, contact us. Okay, all we want is your name, email, and what you're interested in. We'll put you on roster, and as soon as we have someone who's willing to provide some intermittent mentorship, guidance to get you on the right path, we will contact you. Otherwise, you won't hear from us. Okay. So at this point, I want to thank you for watching the video. I really hope you enjoyed it. I hope you took something from it. If you have any detailed questions, shoot myself, Rahil, or Mansi an email. We'd be happy to entertain those. And I look forward to hearing from you all. Thank you again.
Thank you, Tim. I have a question that may be important to those that are watching. Where can service members find scholarships or additional funding to fund their education, especially when you're talking about going, to the master's level or the PhD level, where their Montgomery their post 9/11 GI Bill, or Chapter 31, or whatever type of funding that they're using may run out?
Yeah, that's a great question. So certain schools have the Yellow Ribbon program, and I'm not too familiar with the program, at the moment, but I do know that the VA essentially will agree to, provide additional years of funding. Also, the Edith North Scholarship that was included on that graphic as well, just showing, how veterans are using the 9/11 GI Bill. So that's actually a scholarship that will provide you up to 3 years of additional, no, I take that 9 months. I'm sorry, not 3 years. I don't know where I got 3 years. So it'll provide in 9 months. But to apply for that scholarship, you have to have at least 6 months of your GI Bill left. Now, more extramural funding opportunities. So as an undergraduate, there are a lot of really small scholarships that you can get. And that's where the majority of mine came from, is, just applying through small scholarships through the school. There are some that are tailored to veterans. Most schools have them. And then aside from that, if you want to go for a master's or PhD, it's worth mentioning that some master's programs will pay you a stipend. Okay. Some. But almost all PhD programs will pay you a stipend. Okay, so if your GI Bill runs out, you will still earn, a monthly income. It'll be, see, I'm trying to think now. I think the housing allowance here in South Carolina is $1,800, and the stipend here is about, $2,000 a month. So if you run out of GI Bill money, your stipend will, you'll get all of that back and some. If you're interested in a PhD, of course. And as I mentioned, the master's programs vary widely. It sometimes it depends on the PI or primary investigator, the mentor that you'd be working for, whether they have funding or not. That would really depend on whether or not you could get funding that way. Does that answer your question? Or,
Yes,
would you
sir,
like
it
more elaboration?
does.
Okay, perfect.
Thank you.
Yeah. You have any other questions? I think you're the only, yeah.
Nope.
Mansi, Rahil, if you have any input, please put it in now. As I mentioned in the beginning, they have the experience in the industry sector. So if you have anything that I missed, especially as it pertains to the industry portion, please share it.
For now, I just had to add one point, if you don't mind, like related to the master's and the PhD programs. They always have an option to do the TA to supplement the stipend.
Mm.
So that might come in handy. And as you know, like it's good, like because the basic cost of living is covered. And like apart from that, like additional money can't hurt anybody from the TA.
Yeah, that's a great point. Yeah. In the event that funding isn't available through the PI or through a master's program, yeah, you can TA. So you would be required to, teach part-time for that stipend. But it is certainly an option. It's just a bigger time commitment. But if they're comfortable with committing more time and they're worried about running out of GI Bill money, then they can absolutely opt into teaching some, probably a few hours a week, really. It's not a lot of work. At least for most people, it's not a lot of work. About 10 to 15 hours, I think, is the expected amount of time you're expected to teach to earn the stipend. So good point.
Do you have any specific questions related to the industry? Like I can help answer to the best of my ability.
Well, spoke a little bit about the industry side, but what other careers can someone that's interested in science look forward to in industries?
So to answer your question, like I'll first go over, can you go back to the slide? I can go over that and like detail. I can give some brief explanation about few points that might cover most of the answers.
Yeah, absolutely. Let's see. You want this slide here?
No, the one specific to the industry.
Okay, here.
Because I am from the biotech background and like I also have the pharmaceutical background, so I can answer a question related to those like accurately. Okay, so as I mentioned, like it varies based on experience, and it was not mentioned in the website, so that's why I didn't mention it. But I have met a person like who was my manager, and he did not even had his bachelor's degree. So he was just a high school graduate, and he did some associate course, and he was working as a technician. So that's how like you can enter through the industry if you don't even have a bachelor's degree. That's a like a good thing. And apart from that, like as I mentioned, uh, the jobs are at different levels. So it gives you the flexibility, like if you want to pursue education and also do a side-by-side job, like there are internship opportunities, and the internship opportunities are paid, and it is nice. And also you can build up experience along with those. Apart from that, like as I'll go through the rules. So in the research and development, like it's basic, like you go as an entry level associate and volunteer or like do the job. Then for the for the business development, it's something if you want to pursue your MBA degree. So if you want to go in the management side, that can help. For the sales representative, is the same thing. Like if you have prior experience or like you have a management degree, that can help. For the manufacturing, you can have bachelor's in science, in biology, anything, and that might help. And the companies are different. So starting from the small scale company like a startup, so they have more risk, but they have the benefit of you getting exposed to a lot of techniques you can put on your resume, and that might help you. So there is a risk because like company might not survive because it's a startup. There is no job security. Like it is there for like year or two minimum. But apart from that, like how long the company will run on the startup funding, the seed funding, nobody knows. It all depends on the science and how it turns out. The other thing where there is another company, a type of company is called CRO. And CRO is basically contract research organizations. So for example, if a company is there or any institution is there and they want to do a specific method or an experiment to run, and they don't have the right equipment or the right people, then they reach out to the CROs and they give a lump sum amount of money to do that experiment and get the data. And the ownership for the data goes to the company who is paying for that. So there is another like a field, like CROs is a other kind of companies, and then there's obviously a large companies. They have the job security, but the job description would be too specific. You'll be stuck with like those limited techniques for the rest of the career if you just stick to the large industry. So there's always pros and cons. So like based on like what are the expectations, what are like personal requirements, if you want to grow more, if you are willing to take risk and all, based on that you can go in different areas. I hope that answered the questions, right?
Yes, thank you. And it got me to start thinking about, I know something that may be important to a lot of veterans that have transitioned out, or just anybody that's been in working for a while, is work-life balance. And what does that look like in industry? What does that look like in academics? What does that look like in like government? What does that look like?
Yeah, so I'll touch on the academic portion here real quick. And so, yeah, let me get out of the slides really quick. Okay, yeah, so the work-life balance is gonna depend on where you're at, like how your department runs. If you're teaching K through 12, you might have more of a work-life balance, but at the collegiate level, there's so many factors that influence it. Like I said, how the department runs, the work that you need to get done. It's gonna kind of go up and down in terms of how much you're required to be there. There's going to be really intense, seasons, especially when it pertains to like when it's time to write a grant. As a collegiate faculty member, you're often expected to apply for grant funding, especially at larger institutions. University of South Carolina being one of those. You need to be bringing in funding, okay? Because the school actually gets a portion of that, and also it helps pay your own salary in addition to hiring some staff members and PhD students. And so during those times, you're probably, even if you're not at work, you're probably going to be working. Okay, you're probably going to be working on writing the grant. But then, once your grant is approved and you are well funded, you've hired all the staff you need. the work will get done and it'll be kind of transient to you. So you can kind of take a little bit of a breather and be involved as much as you want. Rahil, Mansi, if you could touch on the work-life balance of industry, I think that kind of sums up the academia side of things. Admittedly, collegiate professor is, the work-life balance might be a con for the majority of the year, but then you'll have portions of time where you can absolutely enjoy yourself.
I can go over the industrial side. So the work-life balance depends on like the place you are working at. So if you're working at a startup, they have limited resources, so they will hire a limited amount of people, and they expect you to do an areas of job, and that will require most of the time. So like even after the work hours, you'll be supposed to working overtime or something, or like sometimes you guys are working on the weekends. But if it's a big industry, there are a lot of money available. They have hired a lot of people, and because there is a lot of resources, the work distribution is amongst all of them, and that's why like a work-life balance is the stable kind of like easygoing. So it's all about like pros and cons, and as I previously mentioned, like it depends on like personal requirement. Like there are some people they want to learn as much as possible in a short period of time so that they can go for the long shot. Like for example, like uh, I was in a large company before, and then I transitioned to a startup. The reason was I wanted to add multiple skills on my resume, and I want to come over here at University of South Carolina for my PhD. So I thought like that would be my best shot, and I did that. So it depends on a personal level. So it varies from person to person and also like your situation, but there is never a good answer for like the work to life balance. What do you think, Tim?
Yeah, I mean, I think I don't have any experience in industry, of course, but I would imagine it just you always are going to have a boss. I think I will say I think it's probably more regulated in industry, right? I'm sure you're paid salary or paid by the hour, and so going in, I'd imagine how much you're going to work weekly. How that compares to academia. You are going to work. You're working for yourself essentially at the collegiate level, particularly. You're working for yourself. I mean, you need to get funding, and so you're going to work as hard as you need to ensure that you put in a competitive application. If you rush through it, you don't put the time in. It's likely not to be approved, and then you're out of a job or something like that. So I would say the best comparison maybe between academia and industry, and you can correct me if I'm wrong in this, but it's the amount of consistency, right? In academia, you're probably going to get more inconsistency in the amount of time you need to spend per week or per month. As I mentioned, it's going to flex. But in industry, you'll have consistent hours that you're expected to work. I mean, does that sound right?
I have one more. I can't even say if it's one more or not, because as you guys are explaining the different pathways, it sparks questions and just interesting things. But you mentioned grants and writing your own grants so you can fund your research and also fund yourself. Is it something that the grant writing process, is it something that you have to learn on your own, or is it additional training that you have to do? What's that? How does that work?
Yeah, that is such a great question. So you were never on your own, first of all. The benefit of academia is that, and this varies, I guess, by institution, but scientists, and faculty members, often are very collaborative. And so at that level, you're never on your own. However, starting out early, from a student's perspective, there are classes that are put in place that put you through weeks of learning how to write basic grant proposals, in addition to classes that you earn credit for, there are writing requirements put in place by the mentor. And there's tons of reading that's involved, in addition to your regularly scheduled hours. So if you're interested in a, post-secondary position, and that's your ultimate goal, you will be well prepared to write grants as a faculty member because you will have done it at the, elementary is probably a bad description, but as an undergraduate, you'll be writing scholarships. There'll be 2, 3, 4 pages, something very small, very basic, and then you'll get to graduate school and you'll kind of up that a little bit. It's going to be a little bit more involved. Your applications, will be increased in length. You'll be expected to be a little more verbose with your descriptions, and things like that. And so it's kind of scaled, right? So by the time you're a faculty member and you're sending in grants that are high stakes, your job depends on these grants, you'll be well equipped to do those. And your mentors along the way, so your undergraduate advisors, mentors, whatever you'd like to call them, they will prepare you at that level. And then as you go on into a master's or PhD program, those mentors, they will also ensure that you're good to go and give you the tools that you need to succeed.
Thank you. We didn't hear too much about the policy side.
Yeah.
Can
So the
someone speak
project
on that?
management sector.
Right. Whether it's project management or anything else that can be done on policy side. In my mind, when I'm
Mhm.
thinking of policy, I also think of government, but I'm not sure if that's the right correlation.
No, that is a great correlation. Just because the government, in terms of policy, a lot of the positions that are open are government positions. I should say, when they come open, they are government positions. However, in terms of like GS positions, government positions, you got to catch them at the right time because people get in those positions and they don't leave. And that's kind of why initially I had wanted to touch on the government sector. It is a major employment path, but it is extremely difficult to kind of break in, through that avenue. It is worth mentioning that veterans will absolutely have an advantage. Of course, as you transition out of the service, you're given all kinds of classes on how to, utilize USA Jobs and, all kinds of other websites that are tailored to recruiting veterans. And so if the occupation were to open, specifically a project management position, or an advocacy position, something where you're ensuring, proper use and handling of animals, or proper use of a particular protocol, or handling of certain reagents or chemicals, then the veterans would absolutely have an advantage, as it pertains. I'm trying to think of another way to put this. NIH is the National Institute of Health. It's a government federal entity. You also have the National Science Foundation, another federal entity. And so within those, jobs open, and they are designed to ensure. So, for example, if you're a faculty member writing a grant, your grant gets sent to someone, and that someone are the individuals at NSF and NIH. And so they are, they can take a number of roles there, but you have people reading your grant and giving it the red stamp or the green stamp. And then you have people that are developing policies, to give those, people who determine whether you receive funding or not. They give them the tools to actually grade, and put your grant on a scale. There's policies in place on how you communicate your data that you find. So if you're a researcher, people at NSF and NIH, because they give you the money, there are policies in place, and they ensure that those are followed in terms of, once you get product, you have to share that with the public. It has to become publicly accessible. So I really like the point that when you think policy, you think government. I think they are very closely tied. I just think that, I looked into, I just threw an Indeed search just to see what jobs are out there, and USA Jobs, and there just aren't as many jobs that are GS related at the moment. As I mentioned, they're a good place to be. So if you ever find one or see one, you just got to be well equipped to go ahead and apply to that job. So you got to do the legwork ahead of time so you're competitive to apply for them. But if you want to influence policy through the government sector, it's absolutely an option. I don't know if that was. I think that was a long-winded answer to maybe your original question. So please tell me if that was sufficient, or if you have a follow-up question.
No, that is sufficient. That's sufficient. Thank you.
Absolutely.
Well, that's all the questions that I have. I thank you guys for coming on and explaining some of the professions that's within science, the careers, and just the different angles that someone can get into. When I think of science, I'm always thinking about medical or something, or some kind of lab, but you don't think about I didn't really think about like project management or anything like that. So that's really interesting to learn. And I'm sure this is going to be interesting for other people, especially the ones that, they're just really not sure and they're thinking just academia is the only way to go. And it's so much broader than that. So thank you for the information. Amazing. And I hope that we can do something like this again in the future, whether it's within science or whether it's within law, history, whatever have you. But this is very informative, and I thank you.
Yeah, thank you for providing the platform. And I think obviously we'll be in communication, but for the recording's sake, just because I alluded to it a couple of times, this network that we're trying to build, this is careers in science, but there are, three other components, related to STEM as a whole, your technology, engineering, and mathematics. And our goal is to find people who are experts in those fields who might be willing, to either put together presentations or be willing to meet one-on-one with veterans to tell them how to, get the position that they have, and how to find success. And so certainly like additional presentations hopefully are down the road. Of course, you and I will be in contact, but, I just say that for the viewers, the veterans who might end up watching the video.
Certainly.
We have some work to do, but we hope to be in contact soon. Absolutely.
Thank you again.
Yeah, thank you. You all have a good one.
You do the same.